Okay, we're going to go over our work from yesterday, talking about increasing and decreasing. Okay, so we've got our graph. And remember, when we're talking about increasing, then we're talking about where is that graph? Where is it going uphill as the little guy is walking? That's what we're talking about. Okay, so the easiest thing to do is to go in and highlight my places where he changes direction. Okay, so if we had a little guy walking uphill, he would change direction right here, and then he would change direction again right there. Okay, now we're able to see three different areas where that guy was walking. Okay. Okay, so if this is what we've got right here, we would say that this would be an interval of increase, right? And then we'd be able to say we've got increasing here. Okay, for this very short part right here, he's decreasing. And then almost immediately he turns right back around and starts increasing again. Starts going uphill. All right. So far we know that we're going to have three different types. We're going to have increasing, decreasing, and then increasing again. All right. So let's see what we got. So if we're only talking about increasing, places where he's increasing, I need to talk about the interval right here and the interval right here. The two places where he's increasing, okay? So if I'm only focusing on just that left side, that means he is increasing for all values, all x values from negative infinity until he gets to right here. Now the x value at that spot is negative 1.3. So I can say that he was increasing from negative infinity to negative 1.3. Okay. Now, I've also got another area where he was increasing. Okay, he starts increasing again right here. Now, that value is 0. And then he's increasing for all values from then on. So we're going to say he's increasing from 0 to positive infinity. Now, if we go back and talk about that one small part where he's decreasing, then we're going to come back to this one little small section right here. So we would say he is decreasing from this point, which is still by negative 1.3, until this point, which is my 0. So I'm going to say that this graph decreases, it goes downhill from negative 1.3 until I get to 0. Now where it says, where is it constant, we're talking about where is this graph flat, like horizontally flat, looking like a line like this. Well, this graph doesn't have any place at all where it's constant, so we would actually say that there is none. There are no intervals where it is constant. Okay, but now if we're talking about our extremas, remember what we said with our extremas. If we've got an absolute minimum, then that means it never gets smaller than one certain spot. Well, if I'm looking at my graph over here, as I go across my graph, it's going to keep on going down, down, down forever. There is no exact spot where it gets to its smallest point. So I can't say that there is an absolute minimum. Okay? Now, if I'm talking absolute maximum, okay, talking absolute maximum, let's see if I can get it lined up again right there. Oh yeah, if we're talking absolute maximum, I'm talking about as this graph goes up, is there a value where it is the absolute highest value? Well, for this one, it actually goes up to positive infinity. So that, and infinity is not a number, so I know there is no absolute maximum that I've got here. So since this one goes down to negative infinity, and then the highest point, it goes up to positive infinity, and infinity is not a number, I can't say that there's an absolute minimum or maximum. I have to put none for both of those. Now, what I can do is I can say that there's a relative minimum and a relative maximum, because those are the points where we are getting those mountaintops and we are getting those valleys, but they just aren't quite the highest point. So if we were to come back to our little spot right there, our vertex that it's got, then we're able to say, okay, I do have a relative maximum right there at the point that we've got indicated, and I would say my relative maximum occurs right here at 1.19. Now remember, I said that's a maximum because that's a mountaintop. That's where we actually hit the higher point. Now the relative minimum is going to be the lower point that I find, which could be right here at the origin. It'd be 0, 0. Okay? So looking at this graph, we didn't have any absolute minimums or absolute maximums, but we were able to find a few relative because we had some spots where we had mountaintops and valleys. All right, let's try number 2. Looking at number 2, first of all, our eyeballs need to look at what's happening at the end of these graphs. I've got arrows, and they go up forever, okay? Now, whenever I'm looking at it, I see this spot right here, and that's where my graph is changing directions. It goes from going negative to going positive. So I know that I've got 2 areas. I've got one of decreasing on the left and increasing on the right. Now, the best thing to do to visualize this is to go ahead and split that graph right down the middle so that I can clearly see my 2 spots. Now, once I've split it, I'm going to say, where is it increasing? Where do I have positive slopes? Or if I had a little guy walking on this thing, where would he be walking? Uphill. Well, he would be walking uphill from my x value, which is 3, because if I look right here, my x value, that's 3, until he's going to always be going uphill into infinity. So I would say he's increasing from 0 to positive infinity. Now, on the left-hand side of my graph, if I'm reading from left to right, it's coming in from negative infinity. So he's going to be decreasing from negative infinity until I get to my line. Well, my line is at 0, so he's going to be decreasing from negative infinity till I get to 0. Now, I want these numbers to match up because that shows that that's my split point. That's my decision maker. Now, for the constant, there's no spot in this graph where it just levels out. So we're going to have to write none. It never has a flattening out point. Now, absolute minimum versus relative minimum. I know I'm going to have some kind of minimum because that graph, it comes down and goes back up. It hits a spot where it never gets any lower than that. So I know I'm going to be dealing with some kind of minimum. Now, since nothing gets done down below that one, that's going to have to be an absolute minimum. That's an absolute minimum because it's absolutely the smallest Y value on that graph. So I know that for this graph, I do have me an absolute minimum, and that absolute minimum is at the point, let's see, at the point 3 negative 1. Now this graph, since the two ends, they go up forever, I don't have any kind of maximum that I can measure. I don't have any maximum with a real number. So I'm going to say that there is no absolute maximum and there is no relative minimum because I have absolute and there's no relative maximum. The only thing that I had for sure was my absolute minimum. All right, looking at number 3. Number 3, it's got 3 different turning points. So let's go ahead and mark those. We'll highlight those. Okay, I know I've got me a turning point right here at the negative 1 value. I've got a turning point right here at about 0.2. And then I've got another one right here at about 2.2. So I've got 3 different turning points. Okay. So let's go ahead and label the points where our graph is increasing and decreasing. Okay, so if we start over here, pretending we've got a little man walking on the graph. He's going downhill until he gets to this point. Then he starts going uphill till he gets to this point. Then he's going downhill again till he gets to this point. And then it's uphill from there. Okay? So now I just need to label. What do I have? I've got one interval where he's decreasing. I have one where he's increasing. I have one where he's decreasing again. And then I have one where he's increasing. So if I'm starting with my increasing intervals, so that'd be right here. That would be if he is increasing from negative 1 to this point right here, which is at about 0.2. So negative 1 to 0.2. Now, I've got another interval of increase down here. So I'm going to say he is increasing from about 2.2. And if he's always increasing from there on out, I'm going to say it's to infinity. So from about 2.2 to infinity, I've got increasing. Well, now let me come back and pick up my decreasing. He's decreasing from negative infinity until this point. Well, we call this point negative 1. So he's decreasing from negative infinity to negative 1. That took care of this one. Now I'm going to come over here. He's decreasing right here from about 0.2 from about right here to right here, which we call 2.2. Now this graph, do I have any places where it just flattens out? Nope. So I have no constants. Okay, let's talk about absolute minimums and maximums, and relative minimums and maximums. Let me get all this out of the way so that we can see it again. Now remember, look at the ends of this graph. On the ends, it's going up forever. Up forever. So if I've got 2 arrows going up forever, I know that there is going to be no absolute max. Because there is no spot where it's absolutely going to get as high as it can go. Okay, so I can go ahead and put none, because both of my arrows are pointing up. Now I do have a relative maximum, because you're looking at it and you go, okay, but I see one hilltop right there. Well, that one hilltop, that could be your relative maximum. Okay? So if I'm looking at it, and I know it's a little bit blurry on my screen, you'll probably be able to see a little better. I'm going to say that my relative maximum is at this point right here. That's my relative maximum. And as best as I can tell, it looks like it says about 0.2. And then about 3.2. But you'll have the exact numbers on your page. Now, relative minimum versus absolute minimum. If I look at my graph right there, I've got to decide, is that relative or is that absolute? So if I look down here, I don't have any values down here that ever get lower than that 1 point. So since I don't have any values that get lower than that, I know that's got to be an absolute minimum. Because that graph will never get lower. So I'm going to have to say I don't have any relatives, but I have an absolute minimum. And again, this one's a little bit hard to see on mine, but you'll have to. I'm going to say that's at about 2.2 and maybe 2, 4, 6, 8, -9, maybe -9.9. You'll be able to see better than me. Okay. So this one had an absolute minimum because it never goes below that value. All right, picking it up. Let's go ahead and separate this one out. Let's go ahead and put it in sections. So I got one section right here. I got one section right here, one here, and one here. So I got a lot of change in directions going on. Okay, let me go ahead and label my sections. Okay, my first one is coming up from the bottom right. So if we had a little man walking on the graph, he would be increasing, and then he hits the top and he starts decreasing again. And then he hits the bottom down here. He starts increasing again. Then he hits this point and he starts decreasing again. Then he hits this point and he starts increasing again. Now, if we notice, he's increasing into infinity. Okay. So if I label my sections, my first section, he's increasing. Second section, he's decreasing, increasing, decreasing, and then increasing. So now what we've got to do is we've got to go in there and label all of those areas where it was changing directions. Okay. So to start out with, let's label all 3 of my increasing intervals. My first one, I'm going to say he's increasing from negative infinity until my x value right here. And that x value is going to be, I believe it's about negative 0.61. So there's my first interval. Now I've got to do my second interval. Got that one. Now I've got to do my second one. So my second interval of increase is from about, let's see what that says, 0.87 until he stops increasing at about 2.5. And then that last interval that we've got to do, we come right here. And this interval starts at about 3.6. And then it's increasing into infinity. So now we have all three of our increasing intervals. Well, now let's go in and label all my decreasing intervals. So I've got two decreasing intervals that I need to label. So my first decreasing interval is going to be from, let's see, negative 0.6 or negative 0.61, I guess, from negative 0.61 until 0.87. And then decreasing again from the values of 2.5 till it gets to, I guess, about 3.6. Okay, so that gives me both of those. Now this graph, is there ever a spot where it goes completely flat? Nope, no spot where it levels out. So there is no area that's constant. Okay. All right, let's talk about maximums and minimums. Let me get all of this out of the way. Let's start fresh. Okay. Now, if we're talking about maximums and minimums, first of all, I got to look at the ends of this graph. I know this graph is going to be going down forever, and then this graph is going to be going up forever. So if I know that my y's are going to negative infinity and then positive infinity, once the infinities get involved, I know I don't have any that are absolute. None of mine are absolute, so I can go ahead and mark none and none. So my maximums and minimums are going to have to be relative. So my first maximum that I'm going to be looking at is right here. So my first relative maximum is going to be the point negative 0.61. And I think the y value is about 10.3. Okay, then I look at my other one. I got another relative max, and that point is at about 2.5 and at about 3.3. 3. Yeah. Sorry, had to double check for a second. Okay, now I come back and I look at my relative minimums, which are going to be right here and right here. So the coordinates of my first relative minimum are 0.87, and let me see, it goes down to about negative 12.25. There's one. And then my second one, it's going to be at about 3.6. And the y is about negative 6.4. So there we go. This one had a whole lot going on. It had 3 intervals of increase. It had 2 intervals of decrease. We still had no constant. Since we had infinities, then we couldn't have any absolutes. But then I had 2 relative minimums and 2 relative maximums. Okay, this next one is not quite as stressful, and the numbers aren't quite as bad. Okay, first things first, let's go ahead and split it right down through the place where it changes directions. Okay, and so then I'm going to label where is it increasing and decreasing. Okay, so on the left-hand side, If you had somebody walking on your graph, it would be increasing on the left and decreasing on the right. So I've got increasing over here, I got decreasing over here. Whew, this one's only got 2 intervals. They're a little nicer here. So from where to where would we say that person is walking uphill? Where is this graph increasing? Well, I know once they hit this mountaintop right here, it's going to stop. But from where on the x-axis are they coming? They're coming from negative infinity. So I have to say that they're increasing from negative infinity until they get to 3. So they're increasing from negative infinity till they get to 3. Now, if we start talking decreasing, we say they start decreasing from 3, and then they're decreasing forever from there on out. So we would say they're decreasing from 3 to positive infinity. Now this graph, once again, still doesn't have any area where it flattens out, so we're still not going to have a constant value. And then I have to ask, do I have an absolute minimum or do I have absolute maximum? Okay, is there an area on this graph where it's going to become the highest value that it's ever going to be? Well, if we look right there, we've got us a mountaintop, right? It never gets any higher than that. No values any higher than that. So this value right here, the absolute top, is my absolute max. Because it never gets any taller than that. So my absolute maximum is going to be at that point 3, -4. Okay, now I've got to look at my ends when I'm talking about minimums. My ends go down forever. And as they go down forever, they're approaching negative infinity. Well, now we know when we start talking infinity, we cannot have an absolute minimum. We don't even have a relative minimum because there's no place that even makes one of those values. So absolute minimum, we got to write none. Relative minimum, we got to write none. And relative maximums, we only have that one hilltop. So we had to put none there. That one was a little nicer to us. Okay, last one on this page. All right, let's highlight our points where it changes directions. So we need to highlight right here on this line. And we need to highlight right here. So I've got 3 different intervals going on here. So my first interval, they're decreasing. It's going down. My second interval is increasing, going up. And then my last interval, they're going down forever. So if I look right here, I've got 2 intervals of decrease and 1 interval of increase. So let's do our decrease first. My first interval of decrease comes from way out to the left, and then it's going to stop at my x value right here, which if I look down here, it gives it to me. That's going to be about -2.1, I would guess. And then it stops. Oh, I'm so sorry, I screwed that up. Where does it start decreasing from? It starts decreasing from negative infinity to -2.1. I'm sorry about that. I screwed that up. Okay, so that's one interval of decrease. Now the other interval of decrease, they start decreasing at this x value and then keep on going into positive infinity. So that x value is going to be at about 0.8, I think. and they're decreasing into positive infinity. Okay. So now I've got both of my decreasing intervals done. Now I've got to look at my one place where it's increasing, which is right here. So it's increasing from this x value, which we said was negative 2.1, until my next x value right here, which we said was about 0.8. So that's got all three of my intervals. Is there a place where it flattens out? Is there a constant? Nope. Still not a constant area. Okay. Now, if we start looking at the ends of this graph so that we can see if we're talking about infinities or not. Looking at my ends, this graph keeps going up into positive infinity. This end goes down to negative infinity. So I've got positive infinity and negative infinity. If we're talking about infinities in both directions, then I know that I've got no absolutes. Okay, so I know I've got no absolutes. Go ahead and write that down. None and none. Okay, now if we're talking about my relative minimum and relative maximum, if I'm looking up here, I got me a relative minimum right there. Because that is a valley, that is a low point. It just doesn't get any lower than that. So that could be a relative minimum. And we're going to call that about, let's see, negative 2.12 and about negative 4 point, roundabout. Okay. Now my relative maximum, that's this guy up here, because it is a high point. So I'm going to say my relative maximum is at 0.8, and then let's see, the y value is at about 8.2. Okay. So that right there, that gives us an answer to our sheet that said polynomials 3A.2, our practice work, numbers 1 through 6.